Hello. This is an amazing place. So this slide is done. I'm Tarek. All right, so about the name, I can't believe I'm actually giving a talk about circus in a circus. That's quite amazing. So I have a few suggestions for the next DjangoCon. I would like the next edition to be the Beach edition. I'm going to write a software called Beach. I have boat. I need to reserve those names on PyPI. Well, I'll do this. White Mount and a place called Mazure. I think it's around here. All right, so this slide shows you what I think is a typical deployment when you are deploying a Django application. So basically, people are setting up an Nginx server and maybe an Apache server. They do that using the root environment on the system, and then they create a virtual env where they have their Django application running. And they use a WSGI server like JUnicorn. Who uses JUnicorn here? Please raise your hand. All right. Or UWSGI? Someone use UWSGI? Okay. I think those are the most common WSGI server you can find out there. And then those servers take care of launching Django processes, and then you start to have more and more server around your Django application. Elasticsearch, Celery, Sentry, whatnot. So at some point At some point you start to have a lot of stuff that are running on your box. And so you need a supervisor. And if you want to supervise your application, you have a lot of tools out there that are available to do this. And one of the most common tool that's used in the Python community, and I guess in the Django community as well, is SupervisorD. Who uses SupervisorD? Okay, who don't use a supervisor? Okay, okay. There is another one called Blue Pill. It's written in Ruby, I think. And unlike SupervisorD, it has a feature that's pretty cool when you need to handle processes on a server, which is the flapping. So basically, when you run a process and it dies, your supervisor will try to start it again. And if it dies again, it's going to try to start it again. And if the process keeps on dying every time you run it, it's called flapping. And the flapping will kill your server because it's going to eat 100% of the CPU by trying to run all the time a process that dies. And basically, one of the main features you want to have when you have a supervisor tool is to have this flapping feature. The ability to detect that a process is doomed to restart all the time. So that's Blue Pill, but Blue Pill is way less mature than SupervisorD. I'm not sure it's still a project that's still developed. And of course, you have all the tools you have on Linux systems. So for example, Upstart, which I think is the one that's now deployed in Ubuntu by default. And Upstart has all the features you need to run processes, but the only issue with Upstart for us Python developers is that it's a system-level tool. So if you have one Django application on one server and you don't do anything else on that server, it's fine to use Upstart or daemon tools or all the tools I've listed there, God, Monit, or whatever. But the problem is, when we deploy a Python application, usually we create a virtual env in our user environment, and then we want the system to run all those servers. And if you're not root of your system, you won't be able to use all those tools to supervise your application. That's why SupervisorD is so popular in the Python community. You can just install it in your virtual environment and just launch SupervisorD as a daemon, and it will take care of everything on your environment. So this is a typical deployment people do in the Django community, which is SupervisorD that supervises all the server you run, and and then upstart at the system level, if you're under Debian or Ubuntu, that in turn supervise Nginx and SupervisorD. Well, I guess I've heard that some people are even using SupervisorD at the root level, but I guess that's a typical setup. But SupervisorD has some missing features. In one project at Mozilla, we wanted to have extra features we didn't find in SupervisorD. We wanted to have the ability to have real-time standard output and standard error. For example, if you run a web application and you want to see exactly what's going on, and you don't want to have like something based on Sentry where you get back some traceback afterwards, you might want to just look at the standard outputs in real time. And it's not a feature that's built in many supervisors tool. You also want to have real-time stats. You can always use top or do some checking with another system, but it's great to have within your supervisor tool the ability to have statistics about the memory and CPU usage on your different processes. That's not my phone. SupervisorD doesn't come with a powerful web console. It has one. Okay. I'm not sure where this plane is going, but... Oh, that's Paris. It has one web console, but you can't do much with this web console. It's just a console where you can see what's running, but there is no interaction with the system as far as I know. Maybe it has changed lately, but the last time I checked, you couldn't do that. I also want to have a remote access to the system. I want to run my web console on another box and use it to supervise processes that are running on another box. Actually, SupervisorD has a XML RPC access, but you don't have any real-time access where you can interact with the system. There is another feature that is really cool to have is the clustering, a way to interact with processes that are across several boxes. For example, if I have a Django application and that runs with the Elasticsearch server and the Elasticsearch is on another box, it would be cool if I could supervise all those processes from the same interface. And last, event-based plugins. You have some systems out there that provides a way to write a plugin on events that are happening on your processes, and it's not built in SupervisorD. Okay, so I had enough excuses to build my own tool. So that's how we launched Circus. So the technical choice, the core of Circus is PSutil. I'll talk about it after. And for all the message passing work, it's ZeroMQ. The web console is written in Socket.io, Bowl, and Gevent. And everything else is just Python. So PSutil, who knows this library? All right, so this is a really cool library you can use to interact with processes. It has a really clean and simple API. You can just point a PID and you can interact with the process. It's super simple. And that's what we use in Circus to interact with all the processes that are running. And when we started to use it, we had a really bad issue with it because it was super slow. And every time we had to supervise more than 10 or 20 processes, everything was super slow. It turned out that there were some bugs in PSutil where it was reading files. Every time you tried, you were calling some APIs. So that that's the Warsaw-Paris flight. Yeah, so PSutil, pretty cool. And we worked with the guy that runs this project, and we fixed with him the bug we had, and now it's super fast. So if you want to interact with a bunch of processes, PSutil is pretty good. On the top of this, we use ZeroMQ. So who knows ZeroMQ? Okay. Who uses ZeroMQ? Okay. Who hates ZeroMQ? Okay. Who tried to use ZeroMQ with gEvent? Good luck, guys. So ZeroMQ really fast. It's a full talk, so I won't talk about ZeroMQ too much. I'll just explain basically what it does. So it's like a smart socket. Basically, you create a socket, and then you can interact with the socket. And unlike a classical socket where you receive and send data and you have to block, wait for the data to come back and stuff like this, it provides very sophisticated patterns where you can say, hey, I'm going to create a pub/sub socket, and I'm going to publish data in this socket, and I can actually register in many processes on this publish socket and get back the data that comes in. And it's only a matter of a few lines of coding, and ZeroMQ has a lot of different transports. I can run ZeroMQ between processes. I can run ZeroMQ between TCP sockets and some other stuff I don't know about. PGM, I'm not sure what it is. But basically, for Circus, it was great to use ZeroMQ because it meant we were able to write each part of our system without the issue of having to write something specific, so we could run the controller in another box for our system. So we just have to say, hey, run this Circus, and I want to use IPC inter-process protocol, or I want to use TCP, so that's pretty cool. And it's used by Python, and the guy that runs the PyZMQ project does a lot of work in IPython, and he did a great library called PyZMQ. It's really good. You should use it. I'm not sure if we have another one in Python anyways. So, and it has a nice I/O event loop. That's basically the tornado event loop. So you can start a tornado loop and just wait for all the events to come from the various ZeroMQ sockets. So this is a slide that's too big. Oh, that's wonderful. I can zoom in and zoom out in Firefox. Amazing. That's a really great software. You should try it. All right, so that's Circus. So basically, Circus is one process called CircusD. In blue, you have the ZeroMQ socket. It has one pub/sub socket where CircusD will send everything that happens in Circus. If a process dies or if a process is brought to life. And that's where you can register to watch what's going on in the system. And there is another socket, recrep, request response, that is used to interact with the system. So for example, if I want to add a new process, I'll use this socket to tell CircusD to add a new process. And there is another process called CircusD stat that's specialized into building stats about what's running. So CircusD stat watches all the processes that are managed by CircusD, and every n second produces on its own socket statistics about what's going on. And that's the socket we use if we want to have a real-time information about the memory and CPU usage of the processes Circus is running. It's separate because it's more robust to have this on its own process, and for some project we might not care about the statistics, so we would just not launch CircusD stat. Because when you have a lot of process, and when those processes are doing a lot of stuff, CircusD stat will take a little bit of CPU on its own. And then we have three end-user interface. So we have Circastop, which is like top, but only for Circus. So when you run it, you only have the processes that are watched by Circus. And this command line tool can be run in another box. So you can do Circastop, point a box, and then you have all the statistic. It's completely unsecure, but it works. And there is a Circus HTTPD, that's the web console, and Circus CTR, which is a simple command line tool that you can use to interact with the system. And the great thing about ZeroMQ is that it's a protocol that's implemented in many languages. So if you want to write a Circus controller in COBOL, you can do it. All right, so little recap. CircusD, that's the daemon that watches all the process. Circus CTL is the command line tool you can use to interact with the system. Top is the top-like application to display the stuff. Circus HTTPD is a web interface. And plugin, well, let me go back here. I forgot to mention this. Plugin is, since we have ZeroMQ sockets, we built a plugin system. So you can write your own program that will interact with the system. So I was talking about the flapping issue, and actually we have a flapping plugin that will just connect to the two sockets and watch what's going on. And in case it sees that a process is flapping, it will stop this process and send an email or an event or whatever you want to say, hey, we're not going to try to start that process anymore because it's dead. And some people in the community have written other plugins. There is a plugin that checks that Redis is really working. So Circus starts Redis, and that's the Warsaw-Krakow flight. And so people have written plugins in the community. It's very simple. You create a class, and you just write a few lines, interact with the two ZeroMQ socket, and you're done. So here's an example of a Circus configuration file. It's quite similar to what you would find in SupervisorD. So you just create one section per program you want to launch. You tell it how many processes you want to run, and that's it. And then you can run it with CircusD. And this is the interactive shell. So when I start Circus CTL, I have an interactive environment where I can interact with the system. So here I launched it, and well, I didn't do it now. And I have a Django application running and some Redis worker. This is Circastop. So I just run it, and it displays in real time what's going on in my system, the age of each process, and the CPU and memory usage. That's a very busy server. And let me show Circus HTTPD. So that's the web console here. So here I have one web worker. This is all my Circus processes, so because I need to watch them too. And here I have 3 running process. If I click here, it adds one. And if I go in a shell and send some loads on my server, it really moves. You saw it? It moves. Hold on. More load. Yeah. Oh well. Very, very fancy application. Hello world. Okay, anyways. Slides. Oh, 10 minutes left. Okay, so the 3 crosses, because I wanted to make a joke here, but I forgot to do it, and yesterday night was a little bit rough. But the idea about this slide is that when you work with DevOps or Ops, it's pretty cool to be able to tell them, hey, this is my Python project, and you'll find on the root of my project a Circus configuration file. Go, deploy it, and be happy. So, okay, so I wanted to talk about one last thing about Circus, which is pretty important. When you run SupervisorD or Circus, like I showed you, there is one small issue. if you run a Django application, you have, in fact, two levels of supervision. You have, in one side, SupervisorD that watches Sentry, SerDD, Elasticsearch, and JUnicorn. And on the other side, you have JUnicorn, which is itself a supervisor. It watches the Django application. So the problem is, I cannot interact with my Django workers or see them in my Circus console because they're not supervised by Circus. What if I could deal with the Django workers the same way I would deal with the Elasticsearch or SerDD or Sentry processes? What if I could add from Circus a new Django worker or just supervise them without having to ask to interact with JUnicorn? So we've added this feature, the Circus sockets, that solves this issue. So basically, when you run Circus, you can launch processes, but you can also bind sockets. And when you bind a socket and when you launch child processes, the child processes are able to accept connection and read and write data on the socket from their parents. In other words, it's a prefork model, and my voice is gone. So like Apache or JUnicorn, Circus provide a prefork model where you can say, hey, I want to bind the socket on port 8080, and I will let the child processes run web applications that are reading and writing data on this socket. And for WSGI application, there is another program called Chaussette. Chaussette means sock in French, which provides a little bridge that will let you run a WSGI application within Circus. So when you run Chaussette, it will use the file descriptors launched by Circus to run your application. So if I want to run Django inside Circus, I can use this tool called Chaussette. And this is my stack. So it's simplified. I have a single supervisor, which is Circus. It can handle several applications, whether they are Django workers or any other kind of worker. And I can tell Nginx or Apache to send data on a Circus socket for my application. So that's really more simple, and that will let me add new Django workers or whatever from the Circus application. And this is an example. So like adding new processes, you can add a new socket. You say, I want to bind a socket on this host, this port. You can also add the Unix socket if you want. And Circus will start, will bind this socket, and then all the workers will be able to interact with it. You see this variable here. It's a variable that will be replaced by the file descriptor of the socket. So in other words, the Django worker process here will run against the file descriptor opened by Circus. Is this clear? Everyone understand? Okay, cool. My mother didn't understand. Okay, so, oh, and cool thing, since it's a socket, since we're using the socket API from the system, it means the load balancing works perfectly well. It's OS level load balancing, and we have the same speed than Apache or JUnicorn when we bind sockets like this. And to be sure about this, I did a little bit of benchmarks, and it turns out that Circus with a G event through Chaussette is a little bit faster than JUnicorn with G event. I'm not sure why, because it's the same, exactly the same architecture, but it was a benchmark just to prove that Circus didn't add any overhead. And in fact, since we're dealing with sockets, we're able to add here a real-time chart of the socket activity. So basically, if I send some load on my app, this should move. Oh yeah, look at that. So you can watch processes, the CPU and the memory, and you can also watch the socket activity. So we're going to add some more feature. From day one, we wanted to have the clustering feature. I want to be able to have a single Circus controller for several servers. I want to be able to have an explicit mode where I say, please start this process on this box, or I want to have a smart feature where it will decide which box it will use, given some rules of stuff like this. So that's one feature we want to add. And I was talking about the standard error and standard output feature, so we have it, but we would like to add it in the web dashboard using WebSocket. I want to be able to click on the process and see the live stream of this process from the web dashboard. That's it. Thanks.